Okay, let's talk about what happens when we try and graph a quadratic equation. Now, for the kinds of quadratic equations we're looking at, the shape of it ends up being called a parabola. There are really two kinds of parabolas. The first one looks like this. So let's give a few definitions about the parabola. First of all, we say this one opens up, sort of like a bowl. We say it opens up. And a parabola keeps spreading out the higher it goes, so it never goes straight up. It continues to get wider and wider. And then there's a special point for this parabola. The lowest point is called the vertex, and in this case, we say the vertex is also the minimum point of the graph, of the curve, of the parabola, right? So this point right at the bottom, we always call the vertex. In this case, that vertex is the minimum point. However, we can also have parabolas that look like this. And this we would say they open down. It's almost like an umbrella. Now in this case, we call this point the vertex. For this kind of parabola, the vertex is the highest part of the graph of the parabola. And then obviously, hopefully you realize that this would be the maximum point of this graph. So we can have two kinds of parabolas, opens up or opens down. Now, I like to teach my students initially when I teach about graphing quadratic equations, I talk about making a rough sketch. A rough sketch on a graph means it's not going to be perfectly precise, but it's going to, in general, sort of kind of look like that. And that's how I like to teach about graphing quadratic equations or these parabolas. Because it only takes, you have to figure out two things, and they're actually pretty easy. They're not that difficult to figure out. The first one is does it open up or down? You're going to see in a minute, that's really easy to determine that. If you look at the equation, you can, within 5 seconds, determine whether it opens up or opens down. And then the second thing you have to do, you have to find the vertex. Hope this sort of makes sense. Once you find the vertex and you plot the vertex, and then if you know it opens up, then you can just sort of roughly sketch in a parabola that opens up that goes to the vertex. Or say you find the vertex and you know that the parabola opens down, you can go plot your vertex and then draw in a parabola opens down. The only thing that's not going to quite be precisely correct is probably the width of the parabola. You can have very narrow parabolas. You can have very wide parabolas. Now the vertex is here and here, but when I just sketch it in, I probably will not have the correct width. If you actually need to know, if you need a more precise graph, you can graph the vertex and you know it opens down or up, and then you can go get you can go figure out a couple of points along your graph and then make it more precise if you're needing to do that. So the question is, if we're given a quadratic equation, how can we figure out whether it opens up or opens down, and how can we find the vertex? So once again, I'm going to write out the quadratic equation instead of what we call the general form, where the a, the b, and the c are the numbers. So for instance, let's go back to the same equation we've been using a lot when we do these examples. So there we go. So now, based upon this, we want to go ahead and try and do a little summary graph, or what I call a rough sketch. First thing we're going to do is we're going to look at, does it open up or open down? This is really easy. It's just the sign of A, where A is the number in front of the squared term. So, for our example, A is 1. Here's what happens. If A is a positive number, it opens up. If A is a negative number, it opens down. Here's how I remember it. From years ago, I just thought of this. A's positive. What does a positive person normally do? A positive person smiles a lot, right? They're very positive. Everything's wonderful. They're always happy, right? A positive person smiles, which is sort of like opening up. What does a negative person do? A negative person frowns, so it opens down. So in this case, right away, since A is 1, which is a positive number, I know it opens up. So when I get ready to sketch it, I know it's going to look like that kind of a parabola. That's why I said for the rough sketch, you need to figure out two things. Does it open up or down? And the vertex, and I said the up or down part's very easy. All you do is look at the sign of A. Now the vertex, let me rewrite this equation as, instead of f of x, y, which we can do, right? F of x and y are interchangeable. So I'm going to call the vertex, it's a point. The x of my vertex, I'm going to call x sub v for x of vertex. And the y of my vertex, I'll call y sub v. And the nice thing is, we have a little formula for the x of the vertex. And what it is, it's negative b over 2a. So if you have your quadratic equation and you know your a, b's, and c's, we can use this little formula and figure out what the x of the vertex is. So we just plug in. I put the negative first, and I go get b. b is 6 over 2 times a. Looks like negative 6 over 2, looks like negative 3. So if I were to try and graph a rough sketch of the parabola, I know it opens up, and I know here at -3, somewhere along here, I'm going to have my vertex. But I don't know the point, because all I know is the x value. I need to determine what's the y of my vertex. And the way you do that is, once you have determined the x of the vertex, you then go and you plug in that value, you plug it in for x. So here's my original equation. If I plug in x sub v in for x and do the calculation, the y I get will be the y of the vertex. Since I'm plugging in here the value for the x of the vertex, it's going to give me the y of the vertex. So the y of the vertex will be -3 squared plus 6 times -3 plus 5. So this is 9 minus 18 plus 5. Looks like -4. So it looks like -3, -4. That's my vertex. And since it opens up, if all I want is a rough sketch, then I can just say, well, maybe it looks like this. Now, I'm sure that's not precisely what it looks like, but that's close. So that's the rough sketch. However, let's take it a step further. And one of the things we can do to get a more precise graph, oftentimes one of the easier things to do is to go back and determine all right, we spent a lot of time in our classes talking about x-intercepts. So for the problem we're doing, let me write it again. Here was the original equation written as a function. It was x squared plus 6x plus 5. And of course, I rewrote it. Since I'm graphing, I put a y in there, so it's a little easier. And we found the vertex to be so if I graph it again, there's my vertex. I know it's going to open up, but I want to make a more precise graph, so I want to get a few points on the graph. One of the easiest things to do is to find the x-intercept. You remember what we do to find an x-intercept? Remember you set y equal to 0 and you solve for x. And when you do that, you found the x-intercept. So what are we going to do here? We're going to solve this quadratic equation. As a matter of fact, we've already solved this before. Matter of fact, we could factor it. We could use quadratic formula. But whatever we do, when we solve it, we found the solutions to be -1 and -5, which are really my x-intercepts. So now if I want to have a more precise graph, I can go graph my x-intercepts. Remember, that's where the graph is going to cross or touch the y-axis. So I go to -1, and then I go to -5, and now I can draw in a pretty precise parabola. So that's what they're going to do in some of the homework problems. They're going to ask you to find the x-intercepts, and then they're going to eventually ask you to figure out what the graph would look like. Now there's one more kind of this can be a little confusing. So far, the quadratic equations we've been looking at have been of this form: ax squared plus bx plus c. But what they like to do in math sometimes, they take this form and they shuffle and move things around. Matter of fact, they sort of do it completing the square, and they come up with a different looking equation. It's actually the same equation, but it's in a different form. I call this, I don't know if the book does it, I call this the standard quadratic equation. Now this new one, where they just shuffle things around, they still have the a here, and actually the a means the same thing. If we want to figure out whether this parabola opens up or down, I can still look at the sign of a. But there's not any more b or c, and instead they have a couple new variables called h and k. Well, as it turns out, when an equation is written like this, h and k end up being the vertex. So if you're given an equation in this form, say for instance you're told you're said, here's the equation, quadratic equation. Maybe they say find the vertex and do a rough sketch. Actually, it's very simple. Because if I compare this to this equation, so I'll just write it right beneath here to make it very clear. I notice my a is 2, my h is 2, my k is 3. So when a is 2, that has the same meaning as in the other equation. It's going to open up. H and k are 2 and 3. Well, h and k is my vertex. So my vertex so now if I wanted to, if I'm going to make a rough sketch, 2, 3, said it opens up. There's a rough sketch. So this equation, if they give you an equation, it looks like it's pretty helpful. Here's a couple little twists you have to be careful about. So once again, let me write. So here, actually I should have told you this. I call this the standard quadratic equation. I call this, I don't know, I don't think the book does it, but to me, to keep them separate, I call this sort of like the parabola equation. So here it is again. Let's say you're given this equation, you know it's a quadratic equation, and it's in the form of this parabola equation, so they do the same thing. They just say what's the vertex and make a rough sketch. Well, A is -2, therefore it's going to open down. Now to get the vertex, this is where it can get a little tricky. Students get confused. And let me tell you the method I use, which works every time, and I think it's pretty simple. Tricky thing is here, the standard equation is x minus h and then plus k. Well, here I have x plus a number, and then instead of plus, I have minus a number. here's what I do to get the proper values for the vertex. I look at this number, including the sign in front of it. So I know this is going to I have to get my h from this. So I think of this as plus 5. And what happens is I'm going to stick the opposite in my vertex. So if I'm sitting here at plus 5, I said my vertex is minus 1, and I take this whole thing, and I also do the opposite. Although I'm questioning myself because let me check my notes real quick. I'm sort of confusing myself with this standard equation. All right, so therefore I do this thing where I take the opposites. Okay, let me go back to this. I was confused for a minute. What happens is, when you determine the h, you look at this and you do the opposite. And then the k just is what it is. So in this case, the h is the opposite and the k is -1. So therefore, if you do a rough sketch, -5, -1, it opens down. All right, so you're going to see some problems in this form, and it makes it pretty easy actually to figure out the vertex, but at first it can be a little confusing.